The 100 Most Common AI Mistakes, a Thematic Breakdown, Part 2. 6. Human Factors and Adoption Pitfalls. 51. Skill Gap Neglect, deploying AI without training users on its capabilities, limitations, and appropriate use cases. 52. Automation Bias, overtrusting AI recommendations and underusing human judgment, even when the AI is wrong. 53. Deskilling Workforce, relying so heavily on AI that human expertise atrophies, making recovery from AI failures impossible. 54. Poor user experience, UX, design, creating interfaces that don't clearly show AI uncertainty, limitations, or how to override, verify outputs. 55. Ignoring psychological safety, punishing employees for questioning AI outputs or reporting errors, stifling critical feedback. 56. Lack of feedback loops, no mechanism for end users or affected parties to report errors, biases, or concerns about AI decisions. 57. Miscommunication of Uncertainty, presenting probabilistic AI outputs, e.g., 85% chance, as certainties to non-technical stakeholders. 58. Assuming uniform adoption, not tailoring training and support to different user groups' needs, literacy levels, and trust levels. 59. Underestimating cognitive load, adding complex AI tools to workflows without simplifying other tasks, overwhelming users. 60. Ignoring the human-in-the-loop need, automating decisions that legally or ethically require human review without providing it. 7. Organizational culture and leadership errors. 61. Lack of executive sponsorship, AI initiatives driven solely by tech teams without C-suite buy-in and resource commitment. 62. Siloed AI efforts, data science teams working in isolation from domain experts, operations, and ethics committees. 63. Toxic move fast and break things culture, prioritizing speed over safety, ethics, and robustness in AI development. 64. Rewarding only technical wins, incentivizing model accuracy gains while ignoring ethical considerations, user adoption, or maintenance debt. 65. Fear of admitting failure, suppressing discussion of AI project failures or negative outcomes, preventing organizational learning. 66. Overhyping capabilities internally, creating unrealistic expectations among leadership and staff about what AI can deliver now. 67. Ignoring employee concerns, dismissing workforce anxiety about job displacement or surveillance without transparent communication and reskilling plans. 68. Centralized control without context, mandating AI use from the top down without input from frontline workers who understand real-world constraints. 69. Lack of ethical champions, no dedicated roles or forums for raising and addressing ethical concerns about AI projects. 70. Confusing pilots with production, treating successful small-scale experiments as proof of readiness for enterprise-wide deployment. 8. Government and societal scale mistakes. 71. Deploying unproven tech in public services, rolling out high-stakes AI, welfare eligibility, policing, child protection, without rigorous independent validation and sunset clauses. 72. Lack of public transparency and consultation, implementing civic AI systems without clear public notice, explainability, or avenues for redress. 73. Algorithmic accountability gaps, no legal mechanisms to challenge or appeal automated government decisions. 74. Ignoring digital divides, deploying citizen-facing AI services that exclude populations with low digital literacy, poor connectivity, or disabilities. 75. Weaponizing AI for surveillance, using facial recognition, predictive policing, or social scoring to suppress dissent or target minorities without oversight. 76. Regulatory lag and fragmentation, failing to establish timely, coherent regulations, or creating conflicting rules across jurisdictions. 77. Procurement without expertise, governments buying complex AI systems through standard procurement processes without technical evaluation capability. 78. Ignoring geopolitical risks, over-reliance on AI technologies or data from adversarial nations without security assessments. 79. Underfunding AI safety research, prioritizing capability development over research into alignment, robustness, and societal impact mitigation. 80. Treating citizens as data points, designing public AI systems focused on efficiency administration over human dignity, autonomy, and rights. 9. Security and safety oversights. 81. Ignoring adversarial attacks, failing to test and harden models against deliberate manipulation, e.g., fooling image classifiers with stickers. 82. Poor data security practices, storing sensitive training data or model weights insecurely, risking leaks or theft. 83. Model theft extraction, not protecting proprietary models from being reverse-engineered via API queries. 84. Prompt injection vulnerabilities, for Gen AI, failing to sanitize user inputs, allowing attackers to hijack LLM behavior via crafted prompts. 85. Ignoring supply chain risks, using pre-trained models or libraries from untrusted sources containing backdoors or biases. 86. Safety versus capability trade-off neglect, prioritizing performance metrics over built-in safety constraints, e.g., in robotics or autonomous systems. 87. Lack of fail-safes and human overrides, deploying autonomous systems without reliable emergency stop mechanisms or human intervention points. 88. Underestimating misuse potential, not considering how a tool could be weaponized, e.g., deepfakes for disinformation, AI for cyber attacks. 89. Insecure deployment environments, running AI models on infrastructure with weak access controls or network security. 90. Ignoring physical safety, deploying AI in physical systems, drones, vehicles, medical devices, without rigorous safety validation for real-world edge cases. X. Long-term and systemic neglect. 91. Ignoring model decay and obsolescence, failing to budget for and plan the ongoing costs of model monitoring, retraining, and replacement. 92. Technical debt accumulation, taking shortcuts in MLOps, testing, and documentation to meet deadlines, creating unsustainable maintenance burdens. 93. Ethical debt, deferring hard ethical questions, will fix bias later, making them exponentially harder and costlier to address post-deployment. 94. Lack of exit strategy, no plan for decommissioning an AI system when it becomes obsolete, harmful, or too costly to maintain. 95. Ignoring societal ripple effects, failing to assess long-term impacts on labor markets, social cohesion, mental health, or democratic processes. 96. Centralization of power, allowing AI capabilities and data to concentrate in a few large corporations or governments, reducing competition and accountability. 97. Underestimating existential long-term risks, dismissing concerns about advanced AI alignment and control as purely theoretical. 98. Neglecting interdisciplinary research, focusing solely on computer science while ignoring insights from social sciences, philosophy, law, and cognitive science needed for safe AI. 99. Solutionism, believing AI can solve complex socio-technical problems, poverty, climate change, without addressing root political, economic, and social causes. 100. Complacency after initial success, assuming early wins guarantee long-term success, leading to reduced vigilance on monitoring, ethics, and adaptation. Remember, AI won't replace you. A person using AI responsibly will. This is NeoMind AI, where we build the future without burning the present. Until next time, stay sharp. The future is today.